All right, in homework 5.7, we are doing a new trick. Let's revisit what we've been doing so far to find the volume. Volume, we can use integrals to find it by doing the integral of various areas at each x dx from a to b. So the idea is, we've got various areas at different places. If we do the integral of all those areas, it gives us a nice volume shape. Okay. The new thing we're going to look at today is what if we have areas that are really easy to do sliced horizontally, but aren't easy to do sliced vertically, which is quite often the case. Well, there's a trick we can use where the volume is the integral from a to b of the area at each y value, dy. And what that looks like is we're basically finding the area of each one of these things that we slice perpendicular to the y value. And here it went from a to b, where x went from a to b. Here y is going to go from a to b. So that's what's going on. That's kind of where the dy versus dx comes in, is which direction you're going. So let's see how this is going to work. Number one, consider the region bounded by y equals x squared, x equals 2, and the x-axis. So this is our region right in here. And we're revolving it around the y-axis. So here's the y-axis. This is the center where we're revolving it. And what that's going to look like is this whole thing revolves around this central line. And we're going to get this weird empty cone in the middle. And I hope we can picture it. It's something, I don't know if I can draw it. It's something that it's going to have a shape that looks kind of like this in 3 dimensions, where there's this like bowl in the middle that's empty and it's filled in. That's what this shape is going to look like. Let's see how to do it. Well, we need to find the area at each y value, because the area at each y value, when it gets revolved around, is going to make these circles. And just like in our last homework, because there's this blank space in between here and here, that's going to make a disk. And so the actual area of each one of these circles is going to be a washer. We've got this blank disk in the middle. And so the way we find this is we do the area of the big circle minus the area of the little circle. So this is one of those things where we do pi times big R squared minus pi times little r squared. This is the area at each y. So the question is, what is the big R? Well, big R is the distance between here and here. This value is always going to be x equals 2. So we're subtracting the x values. One of the x values is 2. We're subtracting the x value at 0, because that's where we're rotating it around. And so the distance between 2 and 0 is 2 minus 0 is 2. This big radius will always be 2, no matter where we are. This distance is 2. Okay. Little r, though, is changing because it's the distance between this function and 0. And this function, we need the x value of this function. So if y equals x squared, we can find the x value because x equals square root of y. We just take the square root of both sides to solve for x. This x value is square root of y. And so square root of y minus 0 is the distance, the x distance between here and here. That's our little radius, which is just square root of y. So the area at each y is equal to pi times 2 squared minus pi times square root of y squared. We're going to do the integral of this. So it's the integral from, we'll figure that out in a second, of 4 pi minus y pi. And we need to see what y goes from. X goes from 0 to 2, but we're going to be slicing it this way. At each y, we're finding the area. And since if x goes from 0 to 2, y is going from 0 to 4. And so that's what we're integrating from. The y values are going between 0 and 4. This is dy. When there's a pi, you can factor that out. So it's just pi integral from 0 to 4 of 4 minus y dy. This is pi times 4y minus 1/2 y squared from 0 to 4. So it's pi times, we get 16y. 4 squared is 16. Half of 16 is 8 minus 8. Sorry, I don't know why I put a y here. 16 minus 8. When we plug in 0, we'll get 0 and 0, so that won't be anything. So it's pi times 16 minus 8, which is 8. So 8 pi. All right, next example. Let's do number 3. The region R is enclosed by y equals x squared. So that's this region right here we're looking at. Okay, and let's do part C. This gets revolved around x equals -1. So here is where we're revolving, x equals -1. So this is the center of our revolution, that's the center of our circles. And we're revolving it like this. It's going to look like this. These are all of our slices. And again, we have got this blank circle here. It looks something like this. This was a terrible circle. These are not what circles look like, but I hope you can, find in your heart to understand that my art is not very good. So we're finding this area. So it's pretty thin. So let's see what we're doing. We have a big radius. It's going to be pi times big R squared minus pi times little r squared. The big radius is the distance between here and the very outside. That's our big radius. So what is this x value? It's part of this y equals x squared part, but we need the x value. If y equals x squared, then square root of y is what x is. We just take the square root on both sides. X is square root of y. So that's what this is. This x value is the square root of y. This x value is -1. The distance between square root of y and -1 is square root of y minus -1. So square root of y plus 1. Okay. The little r is the distance between here and here. This x value is going to be changing. It's on y equals x, and if y equals x, then x equals y. So this will always be the y value. This x value will be whatever the y value is that we're at. This x value is -1, and so again, the distance between them is y minus -1, which is the same as y plus 1. So let's do our integral. It's the integral from, let's see, y is going between 0 and these intersect at 1, 1. And so the y value that they're going from is 1. So we're going from y equals 0 to 1. And what we're integrating is pi times big R, which is square root of y minus 1, plus 1 squared, minus pi times y plus 1 squared. I'm going to factor out the pi. And I'm also going to square these binomials so I can actually do the integral, because the u substitution won't work well on this one. I could do u substitution on this one, but not this one. So I'm going to expand it. The square binomial trick, remember from Algebra 2, is we square the first one. Square root of y squared is y. Multiply these two together and double them. 2 square root of y. Square the last one. This is minus, so minus y squared plus 2y plus 1, square the first one, multiply them together and double it, square the last one. So this is y, let's do the y squared first because that's the highest power. So it's negative y squared. Y minus 2y is negative y. We have plus 2 square root of y, and 1 minus 1 is 0. So this is our integral. It's pi times -1/3 y cubed, I guess I should put my dy here, minus 1/2 y squared. This is y to the 1/2, so we're going to raise the power by 1 and divide by 3/2, which is multiplying by 2/3. 2 times 2/3 is 4/3. This goes from 0 to 1. When we plug in 1, these will all just give us 1, so it's going to be -1/3 minus 1/2 plus 4/3. When we plug in 0, we'll get 0, 0, 0. So we're subtracting 0, but that doesn't really matter. Here we want to get a common denominator. So it's going to be sixths. It's going to be pi times negative 2/6 minus 3/6 plus 8/6, which is 8 minus 2 minus 3. 8 minus 5 is 3. So 3/6 is 1/2 pi. All right, hopefully that helps on your homework. Good luck on the rest of it.